Hello everyone, hope you are doing well. So today our lesson will be Introduction to Mathematical Induction. And by mathematical induction, I mean a way to prove a statement that includes positive integers. So let me show you how can I apply this way on different examples. So first, mathematical induction is just a way to prove mathematical statement. As I said, what kind of mathematical statements? Just statements that include positive integers or natural numbers. For an example, if I have the following statement, which is 1 plus 2 plus 3 plus, at the end, I'm going to reach this natural number n, I assume that my answer will look like n multiplied by n plus 1 divided by 2. So mathematical induction is a powerful tool to play such a statement. And how can we prove it? Actually, all we need is just two steps. The first step, which we call it the basic step, it says, show this statement is true for n equals 1. So we're gonna prove that this statement is true. It is true for the first natural number, which is 1. And I'm going to check it by plugging n equals 1 in the right hand side and in the left hand side. And let me show you how can I apply it. Let's see the left hand side here. And as you can see, n equals to 1, which means I'm going to have just one term on my left hand side, which is just 1. And I'm going to plug it again in the right hand side. So here, my right hand side equals to the following. Instead of n, I'm going to plug 1. So I'm going to have 1 multiplied by 1 plus 1, which is 2, divided by 2, which is again 1. As you can see here, my left hand side and my right hand side, they are the same. So let me write this conclusion, which is left hand side equal to the right hand side. And this is what I call it the basic step, the first step. The second step, which I call it the induction step, which is a little more difficult. You have to assume that your statement is correct for the value k. So instead of n, I'm going to say, assume that this statement is correct. This statement is true for k. And by this I mean, instead of n, if I plug k, I'm going to assume that the following statement up to k equals to k multiplied by k plus 1 divided by 2, I will assume it's correct. And I will use this assumption to show that the statement is again correct for k plus 1. And this is what I'm going to show right now. So we're going to need some space above. So let's take a look how mathematical induction is working here. We need to show that the statement is true for the value n equals k plus 1, assuming that this statement down there is correct. So if I have this statement and I want to show it's not also working just for k, but it works for k plus 1, then I want to show that 1 plus 2 plus 3 up to k plus k plus 1, it will be also equal to the right hand side, but instead of k, I'm going to plug k plus 1. So here I'm going to have k plus 1 instead of k, and again k plus 1 instead of k, and I already have plus 1, so don't forget to add plus 1 here, all divided by 2. How can I show that this statement is correct, assuming that my statement down there is correct? All I have to do is just to plug here instead of 1 plus 2 plus 3 plus until k, which I already assumed it's equal to k plus 1 over 2. So I can replace it by this guy here, which is k plus 1 divided by 2. And I want to check, if I added k plus 1, I'm going to have the right hand side. So let's check what I'm going to have in this case. If I want to add k plus 1, and as you know, k plus 1 is divided by 1, but here I have 2. So I must have the same denominator here and there. So I'm going to multiply up and down by 2, and as a result, I'm going to have the following fraction with denominator 2. Now above, I already have k multiplied by k plus 1. And here I have 2 multiplied by what? By these two terms, which means 2 is multiplied by 1, 2 is multiplied by k. Or if you want to leave it like this, it's also okay. So you can leave your 2 outside, and inside I still have k plus 1. And actually I want to leave it outside because I will notice there is something interesting about these two terms. I have a common factor. Take a look at k plus 1 here and at k plus 1 there. As you can see, I already have a common factor. So to simplify, I'm going to continue by putting this common factor outside. And here I have k plus 1 outside. Let's check what left inside here. I have k plus 2. So I'm going to put them inside parentheses here. And look down here what I have. 2. Now let me check with above. Notice that the right hand side, which is k plus 1, is already there. K plus 1, which is already here, divided by 2, is exactly the right hand side I'm looking for. Which means I already verified the induction step. So I'm going to write here the left hand side equals the right hand side, and the statement is true. So this is how mathematical induction is working, and I hope this example is clear for you. Next time I'm going to show you more examples to make it clearer, and if you have any questions right now, it will be my pleasure to answer. I hope you enjoy your day. Have a good time.